Hello students, we left off here with transformations of reciprocal functions. So now what I'd like to do is do a few example problems with reciprocal functions. So we're going to go ahead and see what these transformations will do. Alright, so right here it looks like I've got a k. I've got a positive k, so it's plus 2. So what does that tell me about my graph? Well, I know that if I do plus 2, it means that all of the points will be shifted up 2 from where they were before. Now, what's also interesting about transformations in regard to these reciprocal functions or rational functions is the fact that not only are all of the points being shifted up 2, but our asymptote, that point where my function cannot be, is also shifted up 2. So normally we have the line y equals 0 is our asymptote. That's under normal conditions. So if that gets shifted up 2, then what we'll see is that y will be equal to 2. So our new asymptote will be here. And that's the line y equals 2. Now, we didn't shift any at all right or left, so our vertical asymptote is going to remain at x equals 0. Interesting. So let's go ahead and plot a few of our original points and then transform them and see what this transformation will look like. All right, so we see here that we have this point, -1, -1, and this point, 1, 1. And that's kind of our anchor in these types of functions. So I know that we didn't list that out in our parent function, but when you think about the reciprocal, right, of 1, it's 1 divided by 1, therefore it'll be 1. And the same thing occurs with -1. So that always gives us a very nice point that will kind of anchor us and tell us where we need to be. All right, and then we have our other points. So we've got our other points that are listed out here. And I'm just going to go ahead and highlight those real quick in orange for you. So we have these other points here. All of these are going to be our original points on our graph. So those points are all going to be shifted up by the same amount. So everything will be going up 2. So just like before, now we're going up 2. So 1, 1 is going to be shifted up 2, and it becomes 1, 3. And all of the other points will follow the same pattern. So this will go up 2, so it'll go up 1, up 2. And then this will go up 2, so it'll go up 1, and then up 2. And then so on and so forth. So this point will be here, and then this point will be here. Then the same thing will happen for a negative branch. Those will also go up 2. So let's just shift every point up 2. All right, and there we go. And now we connect our points to create our curve. And we see that our curve, like we've always seen with transformations, looks exactly like our original curve, except now everything has been shifted up by 2 units. So my new asymptote is going to be y equals 2 instead of y equals 0, and my old asymptote of x equals 0 will remain an asymptote. So my horizontal asymptote changed, but my vertical asymptote stayed the same and is x equals 0. Now, our translation in the left and right directions will act the same way. So x minus 3. Well, we know that h is equal to 3, and therefore we're going to be shifting to the right 3 units. So my my vertical asymptote is going to shift to the right 3 spaces. So now instead of being at x equals 0, it's going to be x equals 3. So we have our new asymptote here at x equals 3, and our horizontal asymptote will remain the same. So that'll stay at y equals 0. So these are our asymptotes, And now it's actually really easy. If we know where our asymptotes lie, we know that our original points are going to just lie at a set pattern away from the asymptotes. So I can plot 1 unit to the right and 1 unit up to plot my first point, and then 1 unit to the left and 1 unit down to plot the other point. And then I just have this set pattern that I can follow. So if I go to 1/2, I know that this will be up 2, and I know if I go to 1/4, this will be up 4. And then the same thing will happen here. If I go to the right 2, I'll go up 1/2, and etc., etc. So now I can connect my curves. And then the same thing will occur here. All right, so we see that transformations are slowly becoming a little bit easier with these, because actually, in my opinion, these are the easiest to transform because you have this nice central point that you're moving around, and everything else will follow it. So everything else will be a set distance away from it. So we know that our vertical asymptote is going to be y equals 0, and then my horizontal asymptote has become x equals 2. And I'm sorry, I just did that completely backwards. So your vertical asymptote is going to be x equals 2. And your horizontal asymptote will be y equals 0. For an a value, like 2 here, it's just a stretch. So it's just like what we were doing before. So things are going to get stretched out. So before we had the point 1, 1. Now my output will be multiplied by 2. So this new point will actually be 1, 2. So when my output here for 1/2 is 2, it'll actually become 4. So this point here will get stretched and it will become 4. And then when I do 4, or 1/4, I'm sorry, it normally will output 4, but instead it's going to output 8, which will end up being off our graph. So we know that we have some point way up here, probably, which we'll be connecting to. All right, so now when I do 2, my output should be 1/2, but instead it's going to be 1, because I multiplied 1/2 by 2. Then when I do 4, well, my output is supposed to be 1/4, but this is actually going to output 1/2 now. So what we see is that we're approaching our vertical asymptote a lot faster, a lot more quickly, and we're approaching our horizontal asymptote less quickly. And then the same pattern will occur for our other branch. So what we'll see is this, and then this, and then you've got 4 and 1/2. And again, it will be approaching our vertical asymptote very quickly, but my horizontal asymptote, it will go much, much slower towards. So it affects the speed at which we approach the asymptotes, but it doesn't affect the asymptotes themselves. So we're going to be approaching the asymptote, the vertical asymptote, more quickly. However, it doesn't change the asymptote itself. And then if we do a reflection, we'll see something else occur. So our original points are graphed here in purple, and what we'll see is that they will just change quadrants. So the things in quadrant 1 will go down to quadrant 4, and the things in quadrant 3 will go up to quadrant 2. So our new points will just be reflected across this x-axis here, or the line y equals 0, and so then we'll have an image that's a little bit like this. So again, it doesn't change our horizontal asymptote or our vertical asymptote at all. but we will see that it affects how the graph interacts with its asymptotes. And remember, those asymptotes are the lines which they approach, but they never touch. So the curve will approach the line, but it will never quite touch the line. All right, next let's talk about analyzing reciprocal functions. So if we're going to graph a reciprocal function, then we want to talk about all of the transformations that are going on. We can do this in a step-by-step process. So let's go ahead and graph this function, and then we'll analyze it. All right, so your two asymptotes are going to intersect at the point -1, -2. So that's the intersection of our asymptotes. And then all we have to do is graph our branches the same way that we would as if -1, -2 was the center or was the origin. So I went ahead and graphed it already, and we see that our two asymptotes are y equals -2, and we got that from doing our k, and we saw that x is equal to -1, and we found that by saying that h is equal to -1, and so that's going to be my vertical asymptote. So when I'm analyzing this function, it means that we're trying to find the different pieces of it that are actually going to be useful to me, right? I want to know all of the information about it. So my vertical asymptote, as we already determined, is going to be x is equal to -1. And when I'm stating the domain, all I need to say is that x is not equal to -1, because that's the only x value which will not give me any y values. And why is that? Well, we'll see in just a second here. Additionally, my horizontal asymptote is going to be y is equal to -2. So, because I know that my horizontal asymptote is y equals -2, my range will be y is not equal to -2. So now we're doing exclusionary domains. So what we're saying really when we say something like this is that x is real, but x cannot equal -1. So it can be any real number except for -1, and the same thing goes for y here. All right, so now let's actually analyze some points and see why it is that this is true. Why is it that my vertical asymptote is so related to my domain and my horizontal asymptote is so related to my range? So first let's talk about our original function. So our parent function, when we have these inputs here, we see that if we input -4, we're going to get -1 over 4. We input -1, we're going to get -1. We input -1/2, we're going to get -2. We input 0. So if I input 0, I get 1 divided by 0, and this is something that we call undefined. You can't define dividing by 0. There's no such thing. So this is undefined. Then you have 1/2, and your output will be 2. You have your input as 1, your output will be 1, and your input is 4. It'll be 1 over 4 as your output. Now let's see what our new function will look like. Let's think of some inputs that we want to use for it to see what will happen. All right, so what we see is that when we input -5 into our new function, right, we've got 1 over 5, -5 plus 1 minus 2. So that's going to be my input for my new function here. So I input -5 and I say minus 2. So that's going to be -5 plus 1 is going to be 1/4. So this is 1 over -4 minus 2. And so the output here is going to be -1/4 minus 2. So it's going to be -1/4 but shifted down 2. And so that will give us, I believe that's going to give us -9 over 4. And if we check our graph, we see that we're pretty much there because that's 2 1/4. So we go over here and we look at this point at -5, and that's going to be right here. And we're at -2 1/4. All right, so there we go. So that point is good. So I'm going to go ahead and fill out the rest of these with reference to the graph. I'm not going to actually input everything, but then I'm going to focus really hard on this -1 and see what happens. All right, so what we see is that that our table now, it has a lot more fractions on it. It also has some other interesting facts to it. But what I want to focus on right now is this -1. So this -1, when I plug it in, I get 1 over -1 plus 1. So that's 1 over 0 minus 2. But the problem is this 1 over 0 is undefined. So I don't know where this number is starting, so I can't subtract 2 from it. This is not a number. 1 divided by 0 is not a number, so I can't actually graph it on the graph. So this is now undefined. So we see that we have to have this undefined point over here at -1, -2. We don't actually are not able to graph it. So our graph will approach it, but we're not going to actually ever be able to do this operation, this 1 divided by 0. So that's our key issue here. Now, some other interesting things are our intercepts. So we now have an x and a y intercept. So while a reciprocal function does not naturally have these, if we shift them around, then they will create some intercepts. So my x-intercept is going to occur here. So this is my x-intercept, and then my y-intercept is going to occur when x equals 0. So this is my y-intercept, and this is my x-intercept. So these 2 points have now become my intercepts. So that's an interesting little fact that's happening right now. So we see that because of the shift, it's caused us to do more analysis, and now we have some more information that we can use. All right, and let's just make sure that we know the transformations that have been performed here. We went down 2, and we went left 1. So as you can see, some of these problems can get very involved. So analysis of reciprocal functions and analysis of our rational functions will be very complicated. So make sure that you take it step by step, do one small thing at a time. We'll have a reduced number of problems most of the time to be able to accommodate that. If you have any questions, let me know, and have a wonderful day. Goodbye.